So have you guys gone through the video that actually I have uploaded on Imparters? Harshit, Meghna, are you able to hear? I think I am audible, right?
Yes, sir, you're audible.
Okay.
Am I audible, sir?
Yeah, you are audible. So have you guys gone through the video? It's a hardly 10-minute video.
Yes, sir.
Okay. So are you guys aware of this centrifugal pump? Only 31 students. So before we begin, I think you have pretty good idea about what is centrifugal pump. But let me ask you, where exactly have you seen this pump? You can tell me one by one, and you can also tell me that actually what was the purpose actually. The people were using that centrifugal pump, right? They use for a lot many different applications. But have you seen this machine somewhere?
Yes, sir, centrifugal pumps are actually the most common type, and they're found in the pumps that we use in our residences are also this type only.
Somebody actually from village who has this farmland. Is there someone?
So yes, the borewells actually work on centrifugal, I think.
Yeah. So when you go to these actually villages, right? What you will see. So of course we get water through rain. That is one. But means lot many times what we do, whether we are actually taking out water from the ground using the same centrifugal pump. Otherwise, what happens? There are these actually canals are there, right? So what you have to do, you have to put one pipe actually in the canal, and then you have to pump in your farm. That's the way. So it's a very commonly used actually pump, and the working principle is also simple. Maintenance is also low, and efficiency. I think you can tell me once you will be done with this experiment, right? So here actually, if you see, right, you can you see the screen, guys?
Yes, sir.
You can see the screen, right?
Yes, sir.
Okay. So I think you have already the centrifugal pump before actually you studied in the fluid mechanics course. That what is the centrifugal pump and what are the parts. So anyone have seen actually that what are the parts there inside the centrifugal pump? You can tell me one by one. What I will do, I will just try to write here, right?
Sir, impeller.
Okay, so first is impeller, right? Second one.
Shaft.
Okay.
Sir,
Any other? Yeah, Vishruta, you are telling something, right?
Yes, sir, I said suction nozzle.
Suction nozzle. Okay, we can say the nozzle, right? But still, if I have these three parts, Means I don't think I can pump the fluid or water, right?
Sir, motor.
Okay, that's good. So this motor can be both actually AC and DC, right? What is the difference? AC you can directly actually, this is alternating current, so we get that actually at our home. This is a 220 volt, something like. And DC is the direct current. Any question? So there is this DC pump, right? So these are the things. So what we have seen, this whatever you have told me, right? These are the things actually we see at our house. So these are the main part. Of course, there is a casing also where the impeller is housing, right? So if we look at front view, it looks like something like this one, where there is this eye and this kind of structure is there, right? So this is impeller. This impeller is connected to the shaft, and shaft is connected to the motor or any mechanical device. So motor normally when we are talking about, at our house, but if you will go to the farmland, right, there they don't have this motor. What do they have? Anyone can tell me. When you go to
Sir,
villages,
where?
right? Yeah. So instead of motor, what is there?
So where are you asking?
So I'm asking actually, so means in our household items actually, these centrifugal pump is connected to the motor. It may be AC or DC, but if you go to village, then normally a lot of villages don't have electricity, right? So there, this actually pump is connected to what?
So they connect those to generators and use petrol some to run them.
Generator is one part. So generator you can't connect actually to generator. Generator has two parts, right? One is the diesel engine, and another part is what? Dynamo, right? That produce the electricity. So what they do actually in village, they connect actually this impeller to the diesel engine, right?
Yes, sir.
The overall idea is actually to get the mechanical power and convert that mechanical power to the hydraulic energy, right? So what is, yeah, so we were here. So this is the impeller, and outside actually this kind of this casing is there, if you see. This is the casing, and it is connected like this one. So here you get what? Here you get discharge. Actually, you are pumping water in this direction. And where you are feeding water, you are feeding here. So I think actually somebody says this nozzle, right? So you were talking about this nozzle here, right? Is that correct?
Yes, sir, like where the water enters from.
Yes. This is sometimes actually it is also called actually I. Now let me ask you one thing. What do you think actually when you are pumping the water, where the pressure will be, let's say, this pressure I will say PE and this pressure I will say PD. This is discharge pressure, right? And this is impeller I pressure. So which one should be higher?
So PD.
Okay, that's right. PD should be higher. Now let me ask you, what should be the PE? It should be positive, it should be negative, or what should be? Right?
So what do we mean when we say negative pressure?
Negative pressure actually you can say means the negative with respect to the atmospheric pressure. Right? So what is actually, what is the value PATM? It's something I think 100 kilopascal, right? Is that
Yeah.
correct? If something, let's say, if I have 80 kilopascal, what does it mean? It's a negative with respect to the atmospheric pressure, right?
Right, so
Hmm. Two things are there. This is actually whatever we take with respect to the atmospheric pressure, that's the gauge pressure. But normally what we do, we actually measure the absolute pressure here at this side, right? So this is typical your what is called centrifugal pump. There are different kind of other pumps also available, but right now what we are interested in, to know the check the head versus discharge curve for centrifugal pump and this pump efficiency versus discharge. So when I say the discharge means you can say the flow rate. Okay? So you can say liter per minute, or you can say more appropriate unit is like meter cube per second, or you can write meter cube per minute. You can also write meter cube per hour, whatever the appropriate is, right? So whenever we will say about the flow rate, actually what we are looking at this meter cube. Okay, so you can convert that. There is a way you can measure. So when you want to plot actually this head versus discharge and this pump efficiency versus discharge, what are the parameters you have to determine? Right? So these are given here, like you should know the pump input. When we say pump input, so what is that? There are two things. One energy you are actually putting in the motor, this one, right? That is what? This in this test rig, I think we have DC motor. So you will be using actually some voltage and current, right? So you can calculate how much energy is given to the motor. Now the thing is actually that's the actual energy you have put in the motor, or you will say, if I will say that this is my motor and it is connected to the pump, right? So this is pump and this is motor, right? So what is the, I'm putting some energy here, right? So I can say like EM if I'm saying. So I'm putting that energy, I'm giving that energy to the motor, but it's not possible actually that this energy, whatever I'm giving to the motor, it is getting transferred to the pump, right? That may not be true. That may be true or may not be true. But in most of the cases, actually, this motor also has some losses, right? That means whatever energy I'm putting, that it will just actually transfer fraction of that energy to the pump. Right. And then in that case, actually, that energy will be pushing this liquid or generating the hydrostatic head. So those things actually we will be measuring, and how do we are going to measure that thing? We'll just go and look at our setup here. If you have any question in between, just feel free to ask. We'll go like slowly. So here, as we have mentioned here, you can see, right? There we are actually giving this energy to the motor, right? So if you will see here in this setup, so this is our setup. Here we have energy meter. This one is the energy meter. So it will tell you actually how much energy we are giving to the motor, right? Then this motor is connected to the pump through what? This is shaft. Now, what are the other actually means component in this setup? We have here two pressure gauge. One is called this PD. There's a discharge pressure. And here we have another vacuum gauge, right? So it will give you the negative pressure. So this is called PS. We wrote here PE, but you can take it as a PS, right? Now there are two control valves. So one is this one and another is this one. What's the need? Actually, we will see that thing. And there is another this measuring tank. this one. So why do we have measuring tank here? Measuring tank, so we can actually, for given RPM, how much this pump is pumping, how much water, or what is the flow rate or discharge, right? That we can calculate using this measuring tank. And then there is a sum. So what we do normally, we don't connect this measuring tank while starting our setup. When we are doing measurements, right, then only we will. So there is one knob actually you might have seen in those videos, right? That you can rotate. So by rotating, what you can do, whether your flow rate is directly going to the sump or during measurement, this actually you can connect to the measuring tank. So that will give you this setup. This one will give you what? Discharge. Or another was flow rate, right? This one. So this is our typical means experimental setup in our lab. So that you might have seen the in video. Now there are few actually parameters. Those are given in the this one. This is given in the manual. These data points. So just actually this EMC given energy meter constant. It's just actually this meter specific. So these are the constant given. Area of measuring tank. So area of measuring tank, this one. If you know the area of this measuring tank, then you have to just measure the height, that how the height is changing. So height as a function of time, right? So you can just measure the height, and based on that, what you can convert the flow rate as area multiplied by the height. So this will become volume. This is means a time. So whatever time is there, you can put delta T here, and that will give you the flow rate, right? So that you can use. And density of fluid, we are using water. So that is 1000 kg per meter square. Motor efficiency, as means I mentioned here, whatever energy we are putting to the motor, it may not be possible that that energy is getting transferred to the shaft. But whatever the shaft energy, actually that is actual energy that is getting transferred to the pump. So we should know the motor efficiency, right? So these are the parameters. Normally you buy a motor, so you will get actually from the company that what is the efficiency. And this is gravitational constant, and this is height of pressure gauge from vacuum gauge, right? So this is height between these two gauges. This one is H, E, G. Why it is important? Just we will know, right? But whenever we are doing this measurement between these two actually gauges, right? PD and PS, we have to take care of this static height also between them, right? Because they are at not the same level in vertical direction, right? If they are in the horizontal direction, suppose that if I have something here, then I don't need to take that thing because they are actually at two different heights. That's why we have to take care of this HPG height as well, right? That will give the static pressure. So we will see actually at where we are going to use that thing. Now let's come. So these are the two objectives. Head versus discharge and pump discharge efficiency versus discharge rate, right? So in your video, you might have seen that how to start the setup, and also you might have seen that you can also change the RPM of this motor, right? So because this is DC motor, so you can just actually change the RPM as well. Now there are actually different kind of AC motor where you can control the RPM, but this is the most simplistic setup. So just we have DC motor. In DC motor, it is very easy to change the RPM. I think you can just change the voltage and that will result in change in RPM. So you can fix the RPM, and then you can what you can look at? You can look at the discharge and what is the these gauge pressures, right? So this is the observation table where you can fill actually what is the RPM, what is the PD, what is the PS, R1 in centimeter, R2. So what is the R1 and R2? Let's see. final level of water measuring, this one, right? So what has happened, this measuring tank, let me put, how does it look like? So this measuring tank has one this glass. Yeah, any question? Hello? Any question? Okay, if there are no questions, that's fine, right? So what are these R1 and R2? They are actually here, those readings. So you can say like R1 and R2, right? So these are this tube height here. So suppose that I have waited like a 1 minute, then I see as the what is called, I'm discharging the water here that is coming from the pump. So what will happen? It will keep rising, right? And it has reached to certain level. This area we know, what is the cross section area? This one. This is A. So what this R1 and R2 will give? It will give me the height change, this water level change here, right? Directly, that I can use to measure my flow rate. And what is this TP? This is the TP. So you have one, actually this is stopwatch. So what you can do, just you can switch what is called take that stopwatch and you can calculate that how much time you have spent between R1 to R2. That's a delta T. Based on that, what you can do, you can just calculate how much, what is the discharge rate. So this table you can fill. The data already, I think, has been provided to you. Now we will come to the calculation. So any question till now? Now we will go to the calculations.
Sir, why is PD more than PS?
Where? Okay, why the PD is more
Because
than
as I know, fluid flows from high pressure to low pressure.
Okay, okay. But what is happening? Let me see. So what is the working principle of centrifugal pump, you know, right? What is happening? The water is, have you studied the force vortex?
Yes, sir.
So what is happening? This impeller, right? It is rotating. And what when it is rotating, actually it is creating some kind of vortex here. And if some fluid element is here, right? It is rotating. So what happens if it is rotating, let's say, with some angular velocity? So what that will generate? It will generate one centrifugal force in this direction, right? It's like you take actually one stone here, put one string and rotate it faster. What will happen? It will generate what? Centrifugal force, right? This centrifugal force is actually resulting in the this pressure head, whatever this pump is generating, right? So now this centrifugal force, it want to move the liquid from, this is the I, from here to here. So here, let's say this is the PD, right? Now, if you look at the continuity equation, whatever the fluid is there, right? If it is moving actually from here to here, then what will happen? Whether some fluid has to come and occupy this one, but if you look at in terms of pressure, there will be lower pressure here. That is called, so they have taken here what? That one PS, right? This is the means what is called mechanism by which you are getting these two pressure. Is that clear?
Yes, sir.
Because whatever fluid element is, right, because of centrifugal force, it has to move in this direction. So actually it is not pressure driven flow. If you see, it's a centrifugal force driven flow, you can say that thing. But so here you are right that here it is moving from low pressure to high pressure. But if I take actually talk about here to here, now you tell me here to here, what is the flow? It is a pressure driven flow or not? Now you have what? Here you have high pressure, right? as you will go along this tube, this high pressure is actually pushing the liquid to this discharge tank. So here, actually, this is the case of pressure-driven flow. I just talk about the pipeline. That's all. But this pressure is generated by what? This pressure is generated by the centrifugal force, by the centrifugal force, right? That's why it is called the centrifugal pump. Is that clear?
Yes, sir. And what happens from some tank to this pump?
Okay, but okay. So what happens, right? So two things are there. When I'm running this centrifugal pump, right? There should always be, the liquid inside this pump. If liquid inside pump is not there, then what it will be actually freely rotating, and that is not good for motor, right? So that is the one thing. So now questions come: why do we want to keep this sump tank, right? This one, so while I'm measuring that actually this flow rate discharge, so you see when I'm measuring, just I'm collecting this liquid in this loop. If I don't have some tank, then from where the water will come? Let's say it was directly connected to this pipe, right? Now what I've done to measure actually this flow rate, what I've done, I have disconnected it completely. Now all the flow rate is going to the measuring tank. So now what happens if there is no water in that? What will happen? Suddenly there will be, first there will be cavitation, and suddenly there will be no water inside this pump, because all the water it has just pumped it in this, right? In that case, what will be? This impeller will be freely rotating at higher RPM, and that will actually damage the pump. So to facilitate that thing, that when actually I am measuring, there should be some backup water in that. That is this sump tank, right? So even though there is no discharge water is coming for a short time, but there are still enough water that can circulate. Is that clear?
Yes, sir. I understood. I was asking from some tank to the pump. Is it pressure driven or centrifugal force driven?
No, it's a pressure, because you know what is happening. When we talk about the centrifugal, right, until it reaches to the eye of the impeller, there is no centrifugal force. So it's a pressure driven force, right? Here, what is happening? This sump tank is open to what? This is open to pre-atmospheric pressure, right? And what is the eye pressure here, if you will see? Eye pressure is
Yes.
lower than the pre-atmosphere. So still here also it is what? Pressure driven flow, right? That's why what happens, if you measure actually what is called the eye pressure, it is always lower than the atmospheric pressure when the pump is running. We should keep in mind, if pump is not running, there is no centrifugal force, there will be no difference between this eye pressure and this one, right?
Yes, sir.
Now there is one more question come, right? We are taking the water, because we know the eye pressure is, this is negative pressure. Now suppose that if I have some liquid, if I want to what is called pump the petrol instead of water, right? So the petrol has some vapor pressure, right? Now what happens if I don't take care of that actually this pressure, and I don't do my calculation that what RPM I should run this motor pump, then what will happen? Because this is here the negative pressure, or you can say the lower pressure, right? So what will happen when I'm running this what is called I want to pump the petrol. Before it will actually go to the impeller, at this place itself, the petrol will vaporize. And when the petrol will vaporize, what will happen? There will be air cavity inside the impeller. And that actually will suddenly reduce the efficiency of the pump. Means it won't able to pump any petrol further, right? So these are the certain actually problems we have to take care, and for each and every what is called liquid, we have to characterize first our pump characteristic, and then we can use actually to pump those liquids. Okay.
Yes, sir.
Any other question? So I think until observation table, everything is clear.
Yes, sir.
No, you should ask questions. Means the more questions are there, the more clarity means we all will get, right?
So
These are the
what
simple
is
things.
the like TP? I did not understand.
This TP is actually in seconds, right? So this TP is nothing but this delta T. You want to measure the what is called this discharge rate, right? So what is happening?
No, sir.
Suppose
Discharge rate time is T. TP is something like time taken by pulses of energy meter.
a minute, let me check this one. Okay, yeah, there are two things, right. Thanks, this thing. So TP, this one is for the energy meter. 1 minute. This is for the energy meter, right? So what happens? Let's look at actually how we are going to use the TP. So as you see, I means told this thing that we have to know, we should know that how much energy we are putting in the motor, right? This is the energy, right? Now, two ways are there. If you ask me, then simple that I should know the current and I should know the voltage. I can multiply and I can get the energy. Is that correct?
Yes, sir.
A simple way. If we don't have energy meter, right?
So
What
we
you
need to
will
multiply by
do?
time as well. Otherwise, this is power only.
Yeah, that you can do. So the current actually, what you will get, you have to convert to the what is called watt, right? So this is watt hour something. So this will be if you run for the 1 hour something. But what information you should have? You should have these two. So suppose that you are feeding this one, right? So what you have one multimeter. So this is multimeter where current is passing. And what? There is also one voltmeter. So voltmeter you will connect between these two things. This is volt and this is ampere. Right? So then we can get actually how much energy we are putting inside this pump motor. Is that correct? Hello?
Yes, sir.
Okay. But in this case, what is there? In this case, we have direct actually this energy meter. This is the energy meter here. So we don't need to actually get the current and voltage separately. What it will be? So you know actually at our home we have energy meter.
Yes, sir.
Have you seen? Right? But this energy meter, I think you means someone from lab is there right now.
Yes, sir. Yes, sir.
Okay. Can you just tell me, tell us what kind of this energy meter we have here?
Energy meter. What kind of energy meter is there? जैसे घरों में होता है ना सबके। सर एनर्जी मीटर जैसा सभी के घरों में है सर, उस टाइप का है जिसे अपनी सर
So it has
यूनिट। यस सर।
so it has the rotating disc one or it's like the digital one?
Sir, this is digital one. So, and here the time taken by pulses of energy meter is that when it is blink for at least 10 times. So that time is taken here, the TP.
So so you are saying actually it has some LED that blinks 10 times, right?
Exactly, sir. Yes, sir. Yes.
Okay, and this when it blinks actually, so what is the means between this the duration between two blinks is actually depending on the energy used, or it is something else?
So it's the 10 blinks the 10 times, then we
Hmm.
take that time, sir. Then after, sir, can I see that formula? Then can go.
Okay, okay. So, so you are saying there is this one LED, so we have to look at the blink, right?
Yes,
Exactly, sir.
yes,
And
sir.
we have, so how much time it will take for these 10 blinks, right?
Yes, yes. 10,
That
10
is
times.
associated TP, right? So suppose that if I am running the motor at the high RPM, that means this TP will be lower, right?
If we increase the RPM, then the time taken by P is increase, sir.
Can you just cross check actually that what kind of this energy meter we have and how do we define this? There is a one, this P is also there, right? Let me see what is the, so.
सर इसमें जब हम आरपीएम बढ़ा देंगे ना सर स्पीड,
Hmm.
तो सर उसका टाइम है सर वो मिनिमम आने लगता है सर, क्योंकि ज्यादा अगर एनर्जी को तो वो जल्दी जल्दी ब्लिंक करता है सर.
Okay, okay, okay,
जी सर.
okay. So you,
जैसे सर
so
हम
you
घर
are
में
saying the energy consumed between two blinks
एग्जैक्टली.
are same, right? This energy is same, right? So if we are actually asking more energy, that means these actually blinks will be faster. So suppose that if I am running, so let's make one case actually, so we can understand a bit better. Just correct us actually in between. So suppose that I'm, this is my RPM, and so I'm running at 1200 RPM, right? And this blink, so these are the 10 blinks, right? It has taken, let's say, 20 seconds. This is TP associated to 10 blinks, right? Now, if I am running this at 600 RPM, now what does it mean? It will take more time or it will take less time?
Sir, more time.
It will take approximately the relation we don't have, but we can say it will take like 50 to 60 or let's say 50 seconds. Is that correct? Please confirm. Hello, am I audible?
Yes, sir, you are audible.
Okay, okay. So this you can actually just look at this one. So what you have to just measure, you have to measure the duration taken by this actually LED whatever this it is blinking means for this 10 blinks, right? Is that okay?
Yes, sir.
And normally what I assume actually this the energy consumed between the one single blink or means between two blinks, that is same. So if you ask more actually energy, that means they will blink faster. That means your TP will go lower, right?
Yes, sir. Are these energy meters similar to what we have at our homes? Because I can see my energy meters also like blinks and these
Huh. So,
LEDs.
so what used to happen actually, if you guys might have seen, right? The old energy meter, there used to be one disc, right? That disc used to have one point, red point. So suppose that sometimes just I'm running fan, then that disc used to rotate at very slow pace. But when I used to run, like suppose that I'm running means what is called in winter, I have switched on my heater or something. That actually disk used to rotate faster, right? What does it mean? That actually what one circle means one rotation of that disk actually was fixed for some unit that was called unit. So one rotation, one unit. The moment I am consuming more actually energy, it is rotating faster within the time for the fixed time, right? So it will rotate more times, means I am consuming more energy during that given, let's say in 1 minute. Now, in this electronic meter, right now we don't have those one. Now we have electronic meter. So they might have put this LED. So this blink is nothing but the similar to that rotation. What we have one. So this single blink is what? This is 1 unit. You can say 1 unit. Just I am giving you example. So suppose that if in 1 minute it is blinking like so 10, just we have fixed that 10 times, but that is not the case. If just I am fixing the time 1 minute and it is actually means blink 60 times, that means I have consumed 60 units, right? So this is the same
Yes.
thing. And I think actually right now we have this electronic meter. I have also seen there is some these LEDs always blinking. Even though there are these LCD there, right? You can see the number. But these LEDs are always blinking. So I think this is a similar kind of meter we have here. This energy meter, right? So just you can just look at. Is that okay? So now
Yes,
there
sir.
are two types. This is for energy meter. And this is what? Discharge rate. Is that okay now?
Yes, sir.
So now all the parameters are means what is called clear. We have RPM at a given RPM, let's say 1200. We will get one PD, one PS, R1 and R2, right? So this is to measure the flow rate, this one. And this is the time to measure the flow rate, and TP that how during the means at what rate it is consuming the energy. So once this everything we have, then what we can do, we can just means use this pump input formula. It will give us what? Actual, let me see, okay. Time taken by pulse of energy meter P, okay. So this is P here should be 10 actually if we are taking. So this P is what? This should be 10 blinks, right? So this from this actually we can calculate that how much energy we have given to motor, not actually to the pump. This energy is given to the motor. Now, if I ask actually that how much energy get transferred to the shaft, right? Now you can use the same formula here, this one. That pump has some efficiency that is given, and that efficiency is always less than 1. So we can see actually if it is given here. This is given 0.8, right? So you can use that thing. So what that means, whatever energy I am giving to the motor, that is not getting actually fully getting transferred to the pump, but only 80% of that is getting transferred to the pump, right? Now this is rise of water level to measure the tank. So this will give us what? This will give us the flow rate. So this one actually R2 and R1, just we can do that thing, and it is in centimeters, so we have to convert to the meter. Once we will get the height, using that height, area is known, this one, R we know, that is the height, time we know, so it will give us what? It should give us the flow rate, this one, as meter cube per second. So that you can calculate, right? Now, what is the total head? So how do you calculate the total head? So here the PD is given that you can measure in the dial here. This one, right? So you can measure the PD. You also know the PS and PS, because actually these dials are giving, I think, reading in mmHg. So you can just actually, what you can do, you can divide by 60. Now one thing, this thing was also added in this one, right? This one is what? This is the same thing. We have to take care of this hydrostatic head between these two dials. So this height we have added here. This one. So this will give us actually head, or you can say actually head is nothing but the water column height that we got it. Now, and once we got this total head, we can actually calculate the pump output using this formula. But now we should know that thing, that this is the pump output, right? So if when you want to know the overall efficiency, what you have to do, how much power, this was the actual power we transferred to the motor. And this is actually power we got in term of the, this, how much pump is pumping. As a means a measurement of this head, right? So this one will be actual overall efficiency that includes motor plus pump. Now when you have to calculate the pump efficiency alone, not actually motor. So what you have to do, now you have to use the shaft output. So that you can just take, you know that what is the pump output, just divided by the how much actual shaft energy is gone. Using that thing, you can just calculate these two. Once you will calculate, then what you have to plot, you have to just, I will just show you that first plot. That is what? This is head, edge versus discharge, right? Now you tell me one thing. If I do one thing, just suppose that there is one wall. This is the wall, right? If suppose that if I close this wall completely, what will happen? What will be the head? So I'm just giving you 1, 2nd, 3rd, 4th, 5th, right? So this is 5th point, or let me keep it. Let's say this is 4, 3, 2, 1. Now, can somebody help me actually what will be the head? This is not actually scale, just I put some numbers. So what I'm saying, I have just closed the output wall. So what does it mean? My discharge is 0. This is 0. So what will be the head? Head is nothing actually. When you close it, then how means what is the height of the water column the pump can maintain? So that will be what? That will be maximum that you can calculate, right? Am I audible?
Yes, sir.
Right. Now you tell me, if I just open that wall completely, when I have opened the wall, what does it mean? My discharge rate is somewhere here. Here. In that case, what will happen? What should happen to the head? The head will go down. So it will come somewhere here. This one. Okay. So if I plot actually, normally if you look at the head versus this discharge curve, they look like this one. What does it mean? You take one pump here, this is this one pipe, you just make it horizontal or you make it vertical. So when you will make, means the vertical means there is no flow rate, means the head will be higher. And when there is a flow, means you have opened the discharge valve completely, means your head will be lower, right? So you will get this just a representation, but similar kind of plot you will get for the head and discharge. This is for a given RPM. What you have to do, you have to repeat the similar actually for at different RPM also, right? So this is the experiment you have to do just to get actually your pump characteristic and what is the overall efficiency and the pump efficiency. So with that, I think we have covered almost everything. Now, any doubt or anything you may ask. Any doubt? The doubt clearing session, you guys should ask, right? If you are not asking, should I start asking? You have the question. Hello? Okay, so let me give you one case study. We have this pump is connected to one pipe here. And this is, I have to pump, right? So this is one well. Here I have this water level and my pump is somewhere. I have put my pump here. And now what I have to do, here my fields are there where I have just put these all the vegetables. Now I have to pump this liquid here, right, to my farm. Now can somebody tell me, I have just connected these two pipes, this one and this one here, right? And I want to pump. Now what I have done, I have just actually put my switch on, my motor is rotating, my impeller is rotating, but what I am observing, no fluid is coming actually here, right? I'm not getting any water here outside this this pipe. So I'm just thinking actually what's the reason why I'm not getting. I have connected everything like as per the manual, right? This pipe is actually inside this water and this one is out. Still this is the pump. Still I'm not getting water. Can somebody help me actually why I'm not getting water? Anyone? I will go one by one. Vishuddha?
Yes, sir.
Why I'm not getting water?
Sir, I'm not sure.
You are not sure? As an engineer, you should not say that you are not sure, right? You should put some logic. Priyanshu? I assume Priyanshu is not there. Shruti?
Sir, I'm not sure, but it may be because we are not supplying enough enough power for that upliftment of water.
Yeah, so you should put your thought right, whether they're right and wrong. First, we should start putting our logic behind the problem, right? So, okay, we'll say I'm not means what is called giving enough energy. You are saying, right? Okay.
Yes, sir.
Okay, Meghna, what do you think? This is a very general problem. That's
Am I
why
audible, sir?
yeah, you are audible, Meghna.
Yes, sir. Actually, I too think the same. But the thing that I think is the pressure that is not enough rather than power, I think the pressure is not enough for the upliftment of the water.
Okay, that's one. Harshit? If you want to answer, I will just assume that you are just switched on and I may ask Mark absent. Keshav? Ishika? If there is no liquid, then what will happen? It will keep rotating, and there means when there is no fluid, there is no centrifugal force acting on the fluid, and then there will be no pressure here. So what did people do? They put actually here some kind of wall, right? And what do they do before they actually start pumping? They put the water in this pipe. What this water will do? This will just go and it will fill this whole pipe and pump network, right? So that is called priming. So once actually the priming is done, priming means this all these actually this pump and pipes are filled with water. Then you can start the pump. So the moment actually it will start, you will start the pump. This pump will start pushing the water, and then I will get the water up. When you will go, actually you are just installing some pump and other thing. You should not do such thing that actually just means you have connected the pump and start running it, right? You have to do the priming. So that is the one priming thing. Another thing also happens cavitation. So suppose that actually if this pump I have put not here but at this place somewhere, right? What will happen as the pump is actually, it is lifting the water. But what will happen if this pressure here, it is going lower? So what will happen? Some of the liquid will vaporize because what happened? It has to suck from this much height, right? Some of the liquid will get vaporized, and when that will get vaporized, it will actually create some bubbles inside this casting. And when that bubbles actually created, they leads to the cavitation. And cavitation can lead to the impeller damage and also your pump efficiency going down. So these are the certain problems that you should be aware while actually designing some system to pump different liquids, right? Is that clear?
So, sir, how could we avoid cavitation?
Cavitation, you can do one thing, actually the simple thing you can ask that, okay, you just reduce this height between these your eye and the water level. First thing is that. Second thing, you should also know what is the eye pressure. This one, right? So once you know this one, then you can choose actually at which RPM you have to run the pump. So as we have means what is called we have discussed, right? If I want to means pump the petrol, right? So two things I have to make sure that this eye pressure should not be lower than the vapor pressure. Otherwise, what will happen? It will just go and it will vaporize the liquid. So those parameters you have to actually design in such a way that you means there should be no cavitation and there should be no what is called this bubble formation inside the pump. So to design that thing, you should know your pump characteristic. And what we are doing here, we are doing the same thing here. We are plotting our head rate versus discharge and also the pump efficiency versus discharge. So suppose that you are actually plotting this pump efficiency versus discharge, right? And what do you see? Suddenly your efficiency has gone down. What does that mean? When the efficiency has gone down, first thing is that actually that the cavitation has taken place, or means inside the pump. That's why the pump efficiency has gone down, right? So you can just find out that at what RPM and what discharge rate you should run your pump for a given liquid. Is that clear? Is that clear?
Yes, sir.
Yes, sir.
So means choosing right pump is another option, but also actually looking at the condition in which you can operate the pump, that is also much more important. For that, you should know the pump characteristic in terms of both head versus discharge and efficiency versus. Right? Any other question? If there is no further question, then any other question is there? If there is no further question, then let's close this session. Is that okay? I think still there are several questions, right? If there is no question, then fine, thanks. I will create the link where you can submit your report. And I think actually the data already has been shared with you. If it's not, then please just let me know. Or if you have any doubt, you can write to me. Okay?
Yes, sir.
Yes.
Thank you, sir.
Okay. Thanks a lot.
Thank you, sir.
But you guys should ask more questions. Sometimes just actually I miss that online, that's the reason. If offline class is there, that's always preferred. So have you guys heard anything about your onboarding?
No, sir.
Still not, right? Anyway, that's fine. Vishwana, you want to ask anything?
No, sir. Do you know anything about when we'll be offline again?
It's a very tricky question, but I think there is something actually, some discussion is going on. So recently, I think soon you will hear something from our director or maybe academic section.
All
So
right.
one thing is there, yeah, I think most of you might have already got your first dose of vaccination, right? Or not?
Yes, sir. I think most of us are complete with our vaccination course. Both of
Right. So I think means still means the discussion is going on, and we have to look at the means the right conditions. Actually, it should not happen that on means you guys just come and then something happen, you have to again wrap up and go, right? So that's fine, but I think yeah, online is okay, but the interaction is the one thing that is somewhere is not there that much. Only few of you ask questions and doubts, but offline it's a different thing, right? There is a lot of learning as well. Although we don't prefer this thing, but the labs means online conducting lab, it's a very challenging thing. So that's why I ask, right? Whatever in the experiment you have already seen, right? Just try to connect with whatever you have at your home. like the centrifugal pump and other experiments. So these are the things like force voltage. So you can correlate the things, whatever, everything you have at home. Just you have to look at with proper mindset, right? So these are the things. You can connect all those things together, then that will help you. So tomorrow, if you go to some industry, right, people may ask this simple question to you. So the thing is actually, you guys should never say that actually as an engineer. First thing is that the answer is must. You should answer the question. We don't expect that actually, 100 times you are right. No, that is not the case. Whenever there is a question, just try to answer, try to understand that thing and try to answer. Maximum what will happen? You may be wrong, but that doesn't mean anything, right? When something is wrong, that's the starting that we think actually then what is the right. The next question is if it is wrong, then what's the right answer, right? So you guys should always have that habit. When there is first thing is you should ask the right question. Asking question is more difficult than actually answering the question. That you will realize sooner or later. So you guys should have developed this habit, asking questions, right? Once you know how to ask the question, then you see how to answer the question. Right? So that is the thing. Just make it habit. When you will go everywhere, you will find actually there is lot many. You will be in a lot many meetings. Somebody will go join some research institute. Somebody will be in corporate, right? In corporate also, there are meetings. There are 100 people. When things come, whether you have understood something or not, 95 people will actually, they don't respond. What does it mean? They have not given actually, they don't understand what's going on. That is the simple case. When you are asking the things, asking the question, that means you have understood something. And that something can be 10%, 20%, 100%, whatever. But at least it should be 10% or 5%, whatever, right? Just make it, it's a means, so for all of you, just make it habit to ask the question. Just start asking the question. Don't worry about right and wrong. You may ask the words most actually like, as such, there is no stupid question, but if we say there is a stupid question, you are entitled to ask though. Nothing wrong in that. Got it?
Yes, sir.
Yeah. So always just means, just make it habit. And never worried about actually that what somebody will say. And no, it is a stupid question. Just there is nothing called stupid question. Questions are questions, and they have to be answered, right? Answer maybe can be stupid, but that is a different case, right? But questions are not stupid. Got it? So thanks all of you, and just start actually making your reports. You can include whatever if you have some photo from your home, from your farm, where you have seen all those things, please do include in your report, right? Okay, so let's close this session, and thanks a lot. Bye.
Thank you, sir.
Thank you, sir.